afternoon, good to your introduction. Shahzad from University. Today my topic is relationship between solid flow rate and riser pressure drop in high pressure circulation system. The prime objective behind this research is to identify a method to calculate the circulating solid circulation rate in high pressure circulating fluidized bed system, because measurement of solid circulation in high pressure circulating fluid system precisely and continuously without any external or internal presence is vital, because heat transfer, mass transfer, and ultimately the chemical reaction depends on this factor. And the ideally measuring method should be continuous and easily calibrated. And in past studies, some researcher attempted solid circulation rate, and they offered some techniques based on detection of particle movement, and like electrical frequencies, optical, and radioactive. But these techniques need intensive optimization, and it is not so many of these measurements result in process interference, and inserted instrument is exposed to abrasion and interference flow. So that's why another option is to quantify mass flow rate based on pressure gauge measurement, which is rare and available only for atmospheric conditions. So that's why the objective of this study is to present a method of finding solid circulation rate in high pressure circulating fluidized bed system. And the effect of system pressure, riser velocity, mean particle dia, and solid circulation rate was investigated on riser pressure drop. The experimental setup was consist of a core model rig, and it composed of major riser, the stripper, regenerator, loop seal, and it is specially attached with a pressure control system. It is directly controlled with a back filter to avoid any particle loss. This is the actual system we have. This is the riser, this is the regenerator, and the stripper, and this is the cyclone. This experiment was conducted in the pressure circulating fluid which has following specification: 2.75 meter high and 0.027 meter in dia. The stripper and regenerator have same height and dia, have 0.9 meter and 0.107 meter. Loop seal is 0.0275 meter. And the different range of operating conditions were set for these experiments. For example, pressure was from 1 to 5 bar absolute, riser gas velocity was tested from 1 to 3.5 meter per second, and loop seal duration 0.1 to 0.4 meter per second. Three different particles of glass size were used: 54.5, 120, and 240 micrometer glass beads were tested. The solid circulation rate were measured by taking the solid flow rate profile. Because this experiment was conducted at various operating conditions, and solid flow rate was measured at steady state condition of certain riser, loop seal condition, and absolute pressure. These solid flow rates were confirmed by taking the slope of the flow rate profile of the regenerator. Here, this one. This one is the solid transformation from regenerator to stripper, and we took the slope of the head, and it also confirmed by taking the steady state condition. This profile was obtained by accumulating the solid particles by cutting off the transformation of particles from regenerator to stripper at steady state condition, and by taking the following method, we calculate solid circulation rate for each case. This is, for example, the transformation from regenerator to stripper. You can see in this profile, the particle when moving towards the other section, their pressure drop is going to decrease, and at the same time, the pileup of particle increasing in the stripper. Results and discussion. As the pressure was the prime parameter in this study, the riser differential pressure decrease with the increase of the system pressure from 1 to 5 absolute 1. And it is because it is dedicated, it is by the contribution by the high density of the gas at high pressure. When we increase the pressure, due to the change of gas density, the riser differential pressure was supposed to decrease, and the effect was more pronounced at high velocity. Same when we increase the gas velocity at different pressure, the same result obtained if there is a decrease in riser pressure observed because of increase in widening in the riser system and at every parameter of pressure. And there is smoother at the high velocity, and there is some more difference at low pressure units, low pressure and low velocity. And for GB 120 micrometer, the same result was obtained when we increase the riser velocity. There is increase in the solid flow rate and decrease in the riser pressure. When we change the loop seal of the system and control the solid flow rate, there is up to certain velocity of loop seal velocity, there is an increase in the solid flow rate was observed, and when saturation point is came, there is no increase in further increase in the solid flow rate was observed. In all cases, in all parameters at the pressure and the different particle size. And the most important concern is the effect of pressure on solid flow rate. There was no significant effect of pressure as such we found on the solid flow rate. It is almost constantly at every velocity and at every pressure. There is no increase in solid flow rate was observed, which was, but you see there is decrease in riser pressure observed, but there is no effect of pressure on solid flow rate was observed. Effect of particle size. The particle, when we keep constant the other parameters, riser velocity, loop seal velocity, and the system pressure, at the same conditions, the solid flow rate decrease with the increase of particle area. In this study, we also calculated the choking velocity, and the choking velocity, the velocity at which this circulating fluidized bed is no more considered as a circulating fluidized bed system. The circulation of the particles hardly there, and the effect of pressure was observed. There is a tremendous effect that we see that choking velocity, irrespective of particle size, decrease with the increase of pressure. So which is attributed to the high density of the gas at high pressure, and due to the effective gas solid drag on between gas and solid at high pressure, and which causes the decrease in the choking velocity. Then by considering all the data, we calculate riser pressure drop, and riser pressure drop was offered as a function of pressure, velocity, and solid circulation rate, and this, you can see that the solid the calculated riser pressure drop and weighted riser pressure drop, it fit our data very well, but there is some discrepancy in the weighted solid flow rate. And here T is a circulating solid circulation rate, delta P is the riser pressure drop, P is the bottom, and Vt is the particle circulation. I think it is because of there is many parameters were included in the equation. That's why we need to modify this equation, this relationship further, and by controlling considering the less parameters. And when we compare our data with the previous studies which was offered by Munazan patients, Markstrom and Corey, we included only Markstrom and Potier in our comparison because Muslim and patients, their relationships offer only horizontal pressure drop between the exit of the riser and the entrance of the side load. So they only offer the delta P, the riser, horizontal point. These Markstrom and Potier, they offer the riser pressure drop. So we compared our data with their correlation, and it can be observed that the Markstrom data underestimated while the Potier data overestimated for experimental data. Solid circulation rate increase with increase in riser velocity, riser pressure drop decrease with increase in pressure. Pressure has no significant effect on solid circulation rate, and equation was developed to predict solid circulation rate at different velocities, system pressure, and different particle size from riser pressure drop. In future, we have planned to riser pressure drop will be investigated for more solid particles of different size and densities, and the developed model will be made more generalized to predict solid flow rates of different particles at high working pressure systems. But at least we have developed a method, non-invasive method to calculate the solid circulation rate at high pressure conditions, because all the previous studies they conducted at atmospheric conditions. So you have observed that the pressure has a tremendous effect on riser pressure drop. It decreases with increase of pressure. So that's why we attempted this study to develop a model at high pressure.